Hi guys, and welcome to the video for adding and subtracting rational expressions with like denominators. So in this video, guys, we're going to add and subtract rational expressions that have common denominators. This is because it's a useful skill in simplifying trig expressions in pre-calc. And you're going to be able to combine the numerators of a rational expression, and then we're going to be reducing these rational expressions, and we're going to do so accurately. So, steps for adding and subtracting. Make sure that you have two or more expressions all have a common denominator. For this section, they're all going to. Step one is going to become more relevant in the next section, and I'm going to teach you ways in the next section of making common denominators. Step two, add or subtract the numerators of all the expressions that do have common denominators. Oof, couldn't say that. Make sure that you're combining like terms, okay? The biggest thing is that in step two, you are essentially combining like terms. And then in step three, you're going to factor any of the resulting expressions. And then you are going to both in the numerator and the denominator, if possible, okay? It is not always possible to factor, but you should just look to remove a GCF. If it's a trinomial, try to factor it, that kind of thing. And then cancel anything, again, if possible. And then reduce any coefficients. So let's take a look. So simplify the rational expressions. Okay, so they both have a common denominator. I can see that 2r squared and 2r squared is the same on both denominators. So the only thing that I'm going to do, okay, like a regular fraction, is subtract the numerator. So 7 take away 11 is negative 4 over 2r squared. Okay, neither of these terms can be factored. So then the only thing that I can do is reduce them. So I can divide negative 4 and 2 by 2. So I get negative 2 on the top. So basically what I am doing is dividing the top and dividing the bottom by 2. I get negative 2 on the top, and on the bottom I just get r squared. And that's a pretty easy one. It's just monomials, but that's basically the process. Okay. Simplify the rational expressions. So what I am going to do is just first note that both of the denominators are the same. So then I can just go ahead and add the tops. So the top here would be x squared plus 7x plus 10. So you will note that I didn't actually add anything together because the x squared, the 7x, and the 10 are not like terms. So all that I can do is kind of push them together in this case. And then I have x plus 5 on the bottom. So the next thing I'm going to do is look at these and say, okay, the bottom is a binomial, and I can't really factor it. There's no factoring to be done. X and positive 5 do not have anything in common. The top is a trinomial, so I'm going to try to factor that. So I'm going to make the whole star as we're used to making for factoring. 10 on the top, 7 on the bottom, x, x. And then, so the two factors of 10 that would add up to 7 would be 2 and 5. So then, my factored version of this would be x plus 2 times x plus 5 over x plus 5. So what I can do now is I can take my red pen of justice here, and I can cross out the x plus 5s, leaving me with nothing but x plus 2. And you could put it like over 1 if you need to, but the end result is just x plus 2. All right, example 3 here. I can again see that the two denominators are the same. So for my answer, I am just going to combine the like terms on the top of the expression. So I'm going to just quick write x plus 5 times x minus 3 on the bottom. Oh, I don't like that 3. And then, so let's combine them on the top. 2x take away x is x here, and 7 take away 10 is negative 3. So on the top, I have x minus 3. On the bottom, I have an x minus 3. So there's no real factoring to be done here. I can just cross out my x minus 3's because I have one on the top and one on the bottom. And it's being multiplied on the bottom. And so when I take out everything from the numerator, it leaves a 1. So I get, oh boy, I get 1 over, and actually I don't need the parentheses here, x plus 5 as my final answer. All right, so we're going to do another one. 2x minus 2x over x squared plus 5x plus 6 minus x minus 2 over x squared plus 5x plus 6. So on the top, so the bottom is going to stay the same. You don't ever add the denominators. And I can note that I'm going to need to factor this for sure. I'm going to come back to that though. I am going to need to factor it. On the top, 2x take away an x is x. And then so I have nothing over here for, so it's like 2x plus 0. So 0 take away negative 2 is x plus 2. Okay, because I have a double negative, negative 2. So then I'm going to factor the bottom because the top is not factorable. So I've got 6, 5, x, and x. So I would get a 2 and a 3. So my new rational expression is x plus 2 over x plus 2 times x plus 3. And then, of course, you can see that I'm going to have the x plus 2 and the x plus 2 here are going to cancel out. So I am left with 1 over x plus 3. Clean up my fraction there. Okay, so now we have multiple rational expressions in a row. Okay, as long as they all have the same common denominator, that's not a big deal whatsoever. All we're going to do is just go across and add all of the numerators with like terms, and then the bottom will still be the same. So on the bottom, okay, of my fraction, oh my gosh, I still have x plus 3. On the top, I have an x squared in the very first part of the numerator, and I don't have any other x squareds. So because of that, it's going to carry over to my final answer. And then I have a positive 5x. Take away 4x is x. So 5x minus 4x is 1x. And then 1x plus 7x is 8x. Positive 8x in the middle. And then 1 take away negative 5. So 1 take away negative 5 is positive 6. And then positive 6 plus 9 is 15. And then I'm not going to be able to factor the bottom, but I am going to factor the top. So I'll do my x, my star. So x, 15, and 8. So thinking of the factors of 15, they're going to add up to 8. I'm going to get 3 and 5. And I'm sure that you can kind of see where this is going. So I'm going to get x plus 3 times x plus 5. All this is over x plus 3. And then, of course, I'm going to go ahead and cancel out the x plus 3 parts. And that's going to leave me with x plus 5 as my final answer. Okay, so I got one more example for you guys. I wanted to do a really complex one. So just follow along here, and hopefully this one can click as easy as the rest of them. So again, the denominator is going to be the same. I like to always start by rewriting the denominator in these cases. It's nice and easy to just kind of get that part accomplished. So now let's look at the top, okay? I have 5x cubed minus, well, there's no cubed term in the second expression, so I'm going to just write 5x cubed as part of my final answer. And then I have no x squared term over here, but I have negative 10x squared. So I'm going to write negative 10x squared. And then I have negative 13 take away negative 13. So negative 13 take away negative 13. So it's really like saying negative 13 plus 13. So that's equal to 0. So my final answer on the top is actually 5x cubed minus 10x squared. So we can go ahead and factor the top. Okay, we can try to find a GCF for this. And if you're noticing, you can take out 5 from both of those. So the new top of the fraction has a 5 out front. And then each of the two top terms, the x cubed and the x squared, have x to the second power within them, because 3 is made up of 2 plus 1. So I can factor that out as well, writing it on the outside to represent the factoring. And then I'm going to divide what's inside. So 5x cubed divided by 5x squared leaves you with an x, because 5 divided by 5 is 1. X to the third divided by x squared is x to the first. There's a minus sign. 10 divided by 5 is 2. And then x squared over x squared cancels out. So the top has factored into 5x squared over x minus 2. And now the bottom, I would do my factoring star of negative 2, negative 3, because one of these has to be positive and one of these needs to be negative. And x and x. So is it possible to make a, is it possible here to make negative 2 and negative 3, negative 2 by multiplying, negative 3 by adding, we can try a variety of factors, but the only factors that negative 2 has in common would have to be negative 2 and 1. And no matter how we arrange those, I know that it looks like it can, but it really cannot actually in this case. No matter how much we really want it to, it's not going to factor, unfortunately. Because if I do positive 2 and negative 1, I get positive 1 down here. If I do positive 1, negative 2, I get negative 1 down here. So unfortunately, we can't factor the bottom. So there is nothing that we can do. So our final answer is x squared minus 3x minus 2 on the bottom. And that is our final answer. So that's it, guys. We're just adding and subtracting rational expressions. It's just like adding and subtracting fractions, where you're going to leave the denominators alone and only add the numerators. If two fractions have common denominators, we're adding and subtracting them by combining like terms. And then remember to factor the resulting expressions, cancel any terms that are in both the numerator and the denominators, and reduce any and all coefficients. So that's it for this video, guys. Thanks for watching, and I'll see you in the next one.